welcome back to the channel. So we're solving September 4th questions. It's working robot simulation, right? So the problem basically is that you're a robot and then you're at the starting point 0, 0 and then facing north. So the robot can receive a sequence of these three possible types of commands, which is either you get -2, means you want to turn left 90 degree, or -1, you want to turn right 90 degree, or anything between 1 to 9 means that you want to move forward the k units between 1 to 9. So it also said that 1 unit at a time. So you're also given the grids of obstacles. So some grid squares are obstacles. There's an array that tell you the coordinate. So if the robot runs into obstacle, then they will instead stay in their current location. Then they'll just go on to the next command. So I'll give you an example, which is from example 2 later to show you how obstacle work. So for example 1, let's say we're facing north, right? So first command is moving 4 steps. So we will end it up at 0, 4. And then we turn right. So we're facing east now. So the next command is move 3 steps. So we're increasing the x coordinate this time because we're going to the right. So we get 3, 4. And then since 3, 4 is the furthest away from the origin point, so we return the distance of this, but in the square way. All right, distance 2 that involve obstacles, and then we'll run into the obstacles. So let's take a look at it. So we're given, let's say this is the origin, this point. All right, so given we have the obstacle at 2, 4. All right, so in the first step, we will move 4 steps, and then we're facing north, so we're going up. And then we want to turn right, so we're facing this side right now. And then we want to move 4 steps. So when we move first step, we reach 1/4 and 1/4. And then the second step, when we try to move it, we see this is an obstacle right here. Maybe a big stone or a giant or something. All right, there's something right here. All right, so instead of trying to go here or something or going through for the remaining steps, we instead just stop here. So we just done processing this one, and then we just look at -2. So -2 is just turn left, so we just facing upward, and then we just move another 4. So in this example, we might end it up, we will end it up in a 1/8, which is the max distance we want to return. Is it was 4 square plus 0 square, and then it get updated when we move here, and then now it get updated to 1 square plus 8 square, which is I think 65. All right, so this is an example, so we'll just go back to the code. Right, so first of all, I will make this obstacle into an obstacle set, so it's easier for you to look up. So set an obstacle set equals to anything for, you can say obstacle for obstacle in obstacles, but a list is not actually hashable or iterable, so you can just make it to be a tuple. All right, and then we can just set xy, which is our current xy, to be 0, 0, and then we can set our distance to be the one we want to return later on, and then we can set our current direction when we're facing north is set it to be 0, and then we just set a direction list to see where we are when we're turning. So this is basically north, and then I think this is the next one I would declare is moving right because we are updating the x coordinate. So this is east, and then south. I don't know why it keeps showing me the screenshot, but south, and then west. So this is x coordinate moving -1, so we're going to the left. This one's y coordinate negative, so we're going to the south. And then since I don't think I need to use I anyways, so I just use command for command in commands. I need to figure this out. Okay. So if command is equals to -2, let's say -1. Okay, -1 means turn right 90 degrees, so we're turning right. So when you turn right, you just move to the next one. So we can say current direction +1. And then since there are only 4, so you want to make sure you mod them. So mod 4. And then we'll just continue to the next one. So if command instead is equals to -2, which means we're turning left, then we can do a +3 instead of +1. Okay. So now we're done with the command. Either there will be -2 or -1. So now we want to actually doing with the moving. So we can say for dash in range command means that for how many times that it is, because we're actually not using it, but if you want to use I, that's totally fine, right? So we can say, we can actually do a dx and dy first to determine which direction we're going to, and then we can take that from the direction site that we're looking at. Okay, so this will give you like 0 or 1 if let's say you're going to the right, so you have 1 for x and 0 for y. So when you're updating like let's say we're moving 4 steps, so we just updating on the x and not updating on the y, right? So we can say next x and next y equals to the current x plus the dx, right? Because we're moving 1 step at a time, plus dy. So if we find that next x and next y is indeed in the obstacle set, then we just spread. So we're not updating anything. So let's say we see, let's say we are here, right? We're at 1, 4. Okay, it's kind of messy right here. Right. Let's say the obstacle is right here. And then we are here. And then we find next xy is 2, 4. Since we found this, and then we just break, so we're not updating anything. But if we didn't, if it's not in the obstacle set, right, then we'll just update it. So after all, every time after one command is done, oh, let me spell something. Okay, after each command is done, we just want to take the max distance to be the x square and y square, and it's the sum of them. And lastly, we just want to return the max distance. Actually, this shouldn't be called max distance. It should call the max distance sum because it's the square of it. Oh, distance is not defined at line 25. Oh, okay. The max of max distance. Yep. Alright, there are like 2 typos right here, which means current direction and current direction. So I think the direction is not updated correctly. That's why something is wrong. Alright, let's submit this. Alright, thank you for watching the video. I hope you like it, and then see you in the next video.